In this tutorial, we will construct a incoherent feed-forward network and analyze its behavior by looking at the control coefficients. So to make an incoherent feed-forward, first we need a gene. Now to make the model simple, we don't need the mRNA step. We're going to just reduce the mRNA step and the translation and transcription into a single reaction for simplicity. So notice by default TinkerCell puts in the mRNA step, so we're going to undo this. We don't want the mRNA step for this model. Then I'm going to copy and paste to create two genes. And now for the incoherent feed-forward, we need an inducer molecule, so in this case S1. And then S1 upregulates, so transcriptional activation. It upregulates gene 1 and gene 2. This is the typical incoherent feed-forward. And now P1 downregulates G2, so I'm going to select transcription repression. Now let's observe what flux controls J4, the final output from this network. So I'm going to select the control coefficients function and look at the controls which flux controls J4, and notice that P1 actually has a very high control over J4, more than J4 itself. And we can actually change that. Escape to clear everything. And I double click on that arc and we can actually adjust the dissociation constants here and here. And now let's say the typical behavior for an incoherent feed-forward should be such that the control is low when S1 is low. So the control of P1 on J4 is low when S1 is low. Let's see if that worked. It seems to have worked. Notice that the controls of P1, so the flux controlling P1, has a much lower control coefficient than J4 itself. And in the situation when S1 is high, let's say 5, then the control coefficient should be much higher for P1. And that seems to be true in this case. Notice that the flux controlling P1 are much higher than the flux control on J4 on itself. And now a steady state simulation should give us the behavior that we want. I'm going to quickly adjust the translation rate here, which won't affect the controls. This is just to make the simulation look a little bit cleaner. So to do a steady state analysis, I'm going to select steady state analysis from this menu of functions. And I'm going to select the S1 variable. So S1 is the inducer molecule that I want to vary from 0 to 5 in increments of 0.1. Okay. Then I simulate. Notice it produces the typical behavior of an incoherent feed-forward, which is that as I induce using S1, the value of P2 goes up and then down. So S1 is an inducer in the beginning, but a repressor at high concentrations.